Living their mark in Germany and in the USA, this company is bringing additive manufacturing to whole new levels with the remarkable machines and the power of 3D printing. Let me introduce Akanadi 3D. Hello, everyone. Welcome to another episode of Builder Nation. Today, we are joined by Yves Hagedorn, CEO at Akanadi 3D. Welcome, Yves. Thank you very much for joining us today. Could you please introduce yourself a little bit?
Hi, thanks, Sam, for having me. Well, my name is Yves Hagedorn. I studied here in Aachen in Germany, which is right at the border to the Netherlands, mechanical engineering. And actually, right here in Aachen, that's the birthplace of laser-based, powder bed-based 3D printing of metals. And so the Laser Institute, I think they were the first ones to have laser strong enough to melt metals. And so I was lucky enough to was in that innovative surrounding. And so that where the company originated.
Perfect. Thank you very much for that. Just the intro, and we already have some really juicy pieces of info. Thank you for that. Before we actually jump into the lasers, before we jump into the whole 3D printing industry, I wanted to ask you specifically, how did you fall into this industry?
Well, right after my studies, actually, doing my studies, I was looking for my, back then, diploma thesis. And so I stumbled across the Fraunhofer Institute for Laser Technology. And ever since, that's like, I don't know, 18 years ago, yeah, I still cannot get enough of this process. The sparkling of the laser, you have a digital part, and then a couple of hours later, you have a complex metal parts in your hand. So I still think it's kind of magic, and it's still fascinating, and we are so happy and proud that we can be a productive part of this awesome community.
That's amazing. We can see that passion that you have for us. Now, in order for us to begin, everybody from scratch, for all of us who might not be really familiar with it, could you tell us how 3D printing helps the additive manufacturing industry? Because of course, this industry comes from many years back, and 3D printing is sort of new. How does it help it?
Well, 3D printing, actually, it's difficult to coin that because that's more for basic understanding, right? I think the idea is printing, but in 3D. So the whole additive manufacturing landscape is sort of referenced to as 3D printing, I would say. In here, we have 7 different, according to Boeing standards, ISO standards, 7 different technologies, and laser powder bed fusion is one of it. And yeah, that's our little niche, so to say. Of course, there are many others like binder jetting or FDM, what the most know, fused deposition modeling, where you have that plastic through a nozzle with which you can print your plastic parts. And for our technology, it's laser based. You have a powder, you melt the 2D information into your powder, and yeah, after a couple of many thousand layers, you have your finished parts.
All right, thank you very much for sharing that. Actually, I was going to ask how your specific Akanadi machines work, but you already gave us a bit of an overview. So instead, I'm going to ask this. Your current flagship solution is the Akanadi 2. It's, I believe, your most recent model. It's your most recent machine. What does this do different than maybe your other models that you have, such as, I believe, the Mini, the Micro, etc.?
Well, what all of our machines have in common is the high modularity. So you can imagine, like for all also conventional manufacturing, the application sort of dictates how the machine looks like. You can imagine dental restorations, tiny parts. The machine is completely different from, I don't know, automotive, where you might have prototypes of combustion engines or by now electric engines. And so how it is bigger, better, faster. The Akanadi 2 is our flagship. It is the largest system. It is designed for full-scale industrial manufacturing. So you have a complete automated powder, refilling, powder suction. You can have up to 4 lasers for maximum productivity, while still being able to manipulate every process parameter for your final parts to have highest part quality.
All right, thank you very much for that. So it's essentially about the size of the needs, right, based on the company, which actually brings me to something very, very cool. Now, I notice you have a lot of different industries and different companies under your portfolio, right? You have BMW, the BMW Group, you have Amexi, you have Airbus, but also you have a lot of institutes. So specifically on this side, how do you support this bunch of institutes with your devices?
Well, what we love, we ourselves come from an institute, right? And back then, since it was developed there, we always had the tools, the basic machines to change everything related to the process, as compared to solutions back then in the business, which were meant one solution for all, which were pretty closed, in terms of which materials you apply, which process parameters you apply. So ideally, industrial institutions or research is a couple of years ahead of industrial application, right? And so we really, really love to be close also to our research customers, because they tell us their needs without being too descriptive about it. They want to publish papers, they want to push the technology, and that's also what we have in mind, right? So that's why, we still have part of our customers in research, while other part of our customers, of course, are applying the technology, to make money.
Right, and actually, these does bring a question to me. So, for what I understand, usually the people that work in research use 3D printing materials more for prototyping, other than for actual production and manufacturing as a whole, right? Is that your case? Is that the case with your customers? And if it is, does that mean a difference in the kind of service you provide? Like, do you sell the machine? Do you sell the service?
Oh, well, to begin with the last question, we sell machines mostly, but of course we also do service and testing applications. Why is that? Well, you can imagine there are so many different metals out there for so many different applications, and all of these materials need different process parameters. Aluminum has a different melt pool than steel, for instance, right? So you need different process parameters. You need to do your homework after all to figure out which parameters to use for which application and which material, right? So that, just having pointed out, for some industrial applications, still one of the holy grails, so to say, is developing new materials for precise applications, right? Just take a turbine of a jet engine, so to say, right? If you could just have a couple of centigrades more temperature within that jet engine, it would be by far more efficient. So now people are looking into new materials, and the beauty of our process is the powder itself. You can just mix it, so to say, put it in the process, and you have an in situ alloy of some new material nobody else would have ever seen beforehand. And to me, that's really fascinating with magic.
Actually, that is pretty unique, I would say. One of the questions that I had precisely was if you work with different materials, depending on each customer. But I believe that it's better to go into a little bit of a secondary question. I saw on one of your recent news that in one of these materials you reached a milestone, which is pretty much that you improved the performance of it, or you made it faster, I believe. How do you, as a 3D printing company, as an additive manufacturing company, how do you become so good at one specific material? How do you make your machines good with that material?
Well, mainly key is the personal, to be honest. So it's we have staff who's also, like myself, really excited about the whole technology, right? And since our machines are so flexible and are also used in research, of course, we can use our own machines to do the exact same thing, right? And so it's quite straightforward for us to use magnesium, for instance, for medical implants. After you did a lot of workout, you might take some magnesium pills for sore muscles. So the same mechanism holds. Magnesium is bioresorbable, for instance. So that's one application. Others might be super high temperature nickel superalloys, so to say. And since our machines are flexible and our staff are really motivated, right, and they know what they do, that is the secret ingredient, I would say, towards pushing the boundaries in having new materials and, of course, more productive materials.
All right, thank you. And so, if I were a newcomer customer, right, somebody that wanted to hire your services or buy a machine, for example, what kind of path would I follow to discover which is the best material for my project?
Typically, since the whole technology is quite new, customers typically would not change the technology and the material. So imagine you have a machine or a part which is manufactured with conventional manufacturing methods, such as milling or turning, right? If they do so, they know their material. And most engineers choose a certain material for a certain reason. It's mainly elongation or strength at break or stuff like that, right? So if they think about using the new technology to exploit the advantages, which are high complexity, for instance, right? Lot size of one and stuff like that, then they typically like to stick to their known materials. If they know the technology already, then they might want to push the boundaries to mix a little bit some voodoo into your powder and maybe have elevated mechanical properties. So that's typically how it goes. So we are lucky enough that our customers mainly know quite well what they want, what they have in mind, and we just have to react and talk to them, listen to them, and try to deliver highest customer benefit.
All right, thank you very much for that. Now, I also have a little question regarding what you mentioned earlier about that you started an institute. I saw that now you moved into a 10,000 square meter super site, right?
Almost in October, but yeah.
Okay. I saw that number on your news, but it's amazing that you've come this far for the last maybe 9 years, I believe it was, right? Since you started it. What does the
I'm losing you again. Sorry, I cannot really hear you.
All right. A second. All right. Can you hear me better?
Oh, yes.
All right. I just moved a different microphone. Anyway,
Beautiful.
Going back to the same question. In such a big site that you currently have right now, what does the day-to-day look like for a company like yours? Why do you need so much space?
Well, the machines are big. Those are wheel tool machines, right? They are easily 3 meters wide, which is 10 feet, I guess, right? 3 meters high, another 10 feet. So quite large machines for relatively small parts and comparatively, but still you need a lot of infrastructure in there, right? And so that's one of the main reasons, right? You have your electrical cabinet, stuff like that. And of course, since we do so much research, we also need quite a lot of office space, right? And that's basically why we had to grow like this from staff and from space.
That's amazing. Thank you very much for that. Now, also, I'm curious, what does your shop look like when not only for the part of the machines working, but also when you're developing new machines? What does a shop look like for a company like yours? I'm curious about this.
I wish it would be more tidy, but other than that, it looks quite organized. We have one part of our shop which is dedicated only, which we call job shop or testing facilities, to our own development of new materials, right? Then we have one part of the shop where, we try new hardware, where we try new sensors, where we try to improve certain modules to have evolutionary improvements. And these modules are basically the sum of what one machine is made of, So we basically improve single modules. So we have like 20 module workshops, like smaller workshops, where our engineers play around a little bit with electricity, with some laser and stuff like that. And mainly or most of the time, you see if something great is happening down there, if like a couple of people stand around, like in awe of what's happening right there. And then it's worthwhile to join them and check out what they have might just have this
Right.
style,
All right. Thank you very much for that. And I mean, I'm curious because of the following. You're the CEO of this company, and I want to poach your brain from that perspective, right? You have a lot of customers, the machines. Now you also have this development shop that you have. You have a lot going on. How do you do it? How do you keep track of budgets, of procurement, of supply chain? How do you keep track of all of this work?
That is actually quite a challenge, quite a task. We do that actually with data science. There are tools like Power BI, stands for business intelligence, which allows you to sort of tap on data bases for our procurement system. We have another database for our staff management system, right? And if you take all that together, you can sort of get an idea of how long or how much work went into one new model and how much hardware went into the exact same module, and that allows you to keep track a little bit. And of course, yeah, we have my dear sister, who is our CFO, and of course, she also keeps track that we don't die of the typical engineering disease of always wanting the best and developing for the longest, because yeah, 1000% solution is great, but typically nobody pays for it. So it might be better, yeah, to have those evolutionary increases or improvements, which I talked about beforehand, right? So it all begins from customers, and yeah, we just listen to them and we do our homework, and yeah, keeping track of the numbers is challenging, definitely.
And speaking about customers, how do you find a product market fit for your machine specifically?
We are quite happy in a way that customers typically approach us. The additive manufacturing landscape is still quite small. You know, people know each other, so to say. And if customers have a specific need for some niche application, they also know that they might not get that need fulfilled by anybody else, you know. And so we are also lucky enough that within the last 9 years, we got quite a good reputation of listening, of delivering high quality products. And that's why they come to us. Plus, we have an online machine configurator. So similar than with a car configurator, you can go online and configure, okay, I need that, I need that, I need that. And that helps in getting a quick answer to the customer of what a potential budget might be. And yeah, then we talk with the customer and check out yeah, if it might be a fit.
Wow, you're living the sales dream. That's amazing. Thank you for sharing that. And now, moving back also into the part of the customers, and given the fact that you're based in Germany and in the US, are there a lot of differences between these two sort of Europe and US based companies? Maybe because of regulations, maybe because of product needs, etc. Are there a lot of differences there?
There are definitely. I mean, I was lucky enough to be able to spend half a year in high school when I was 16, you know, and get another internship in Ohio when I was a little bit older, you know. So I believe I know a little bit or learned to love the American culture, so to say. What's different, of course, in Europe itself, there are a lot more vacations, holidays. People work 40 hours, you won't reach them over the weekend. And that's difficult to understand for an American, so to say. They have a different work approach quite often, you know. Also in Germany, if you get a kid, you have 2 months off. Also if you're a guy, you know, and that's good. That's good for work health balance, so to say, life work balance. Still, that makes it a little bit challenging sometimes, right? But I believe that's the fascinating fact about that. Yeah, get to know the different cultures, also doing sales, learn what they need, what they are used to, you know. In terms of regulations, there's not that much difference because ASTM or ISO, EN standards, they try to be aligned somewhat because, well, after all, we live in one world. There is one big market, you know, so it wouldn't make any sense to be too separated here. So that's also why we try to get good ideas into those conventions, so to say.
I did not expect the question to be so people related. That's actually pretty interesting. Thank you very much.
It is all about people, actually. It is.
All right. That is actually pretty cool to know. Thank you very much for that. Now, speaking of people, one big part of additive manufacturing, and I would dare to say of all engineering related industries, are conventions, events, etc. Right? And I've seen that Aconity took part of the last Form Next event. For all of us who might not be aware of what this event is, could you please tell us more about it and your participation in it?
Well, it's the, I would say, leading fair trade worldwide for additive manufacturing itself. Lucky enough, it is in Germany, not too far from here, 3 hours. That might also stem from the fact that, back a couple of years ago, all manufacturers for laser-based 3D printing of metals were German, actually, since it was invented here. Now, some companies got sold, which is, like the business goes, I guess. But still, it's fascinating because it's always like a family reunion. You know, like I said in the beginning, the industry is still really, really small, and competition is barely seen as competition because the whole market is growing, you know. And I believe all companies have plenty to do in getting their market share, their customers happy, you know. And so I myself have the impression that it's still a real amicable meeting, a real nice culture there. And that's why we love to be there. First of all, to show what we have. Also, the beauty of additive manufacturing, since it is quite a new technology, you always get the chance of showing like world records. So you just got to choose the niche small enough, so to say. Then it's quite easy to say, okay, we were the first ones ever done it, you know. So a couple of years ago, we were the first ones implementing a high brilliant green laser for processing copper, for instance, or stuff like that. Now we have an closed loop power control for the laser power doing melting, you know. And so these little world records, so to say, make us incredibly proud, and we want to show off. And so it's great for the team of Econity, but it's also great to meet friends from back then also in other companies and exchange a little bit where the whole industry is heading, what or how we can all participate and make this a better more sustainable industry.
Amazing. Thank you very much. Now, given the fact that the industry is such in diapers, if you want to say it that way, I'm curious, do you believe that the industry is still in that stage where everybody tries to help everybody to make the industry go forward? Or is it already turning a little more competitive, sort of selfish, maybe from one or two companies? Where do you think it stands?
It depends a bit on the company, of course. I mean, if you are a company and you're not doing good, then of course you need to be a little bit more selfish, right? If you are lucky enough that you are doing good, which most companies are actually in the field, then I think you try to join forces, to use synergy effects after all, right? Because it doesn't make sense if each company develops their own solution for, I don't know, data preparation, for instance. I mean, there are other companies who do that just fine, you know. Why not use those sources and join forces and try to focus on the important pressing issues, like productivity, for instance, and reliability and stuff like that, to change even more into true industrial production. There are some niche applications, but it could always still be more, right? And that's what we want to achieve as well. We want to be part of where the laser hits the powder. We want to be part of industrialization of additive manufacturing. And that's the beauty of it. And it's quite still a lot of fun.
That's, I have to say, that is the answer of a leader. Like, it's amazing. Thank you very much for that. I believe that this nice thought of cooperation is a great way to start a closure of this interview. But before we go, Yves, I have to ask you, you are a leader, you're an engineer, I believe, you're an entrepreneur. What advice do you have for every young person out there who might be starting their own path in the industry or just in business as a whole?
Customer first. People believe, and mostly engineers, we need a great idea, and they wait for that great idea. You don't need a great idea. And a restaurant is not a new idea. You just need to be better than the restaurant around you, you know? So it's that operative excellence, maybe. Do whatever you do it at precision. And customers, don't forget about the customers. There's no need in developing anything nobody needs. And so there is this great book, Lean Startup, which I read, and I think it's a great read, and that helped a lot in having those little balloons of trials, see what the market is capable of doing, you know. And I think that's one of the secret sauces.
Perfect. I believe that is an amazing piece of advice. Thank you very much for that. I think it's a great way to bring this episode to an end. So thank you very much again for sharing all of that. Yves, it's been a pleasure having you here on the podcast. Where can we find you? Where can we find Econity 3D? Do you have any social media handles?
Yes, actually we do. So our name, I know for Americans a little bit difficult to pronounce, but Econity 3D with an ACONITY 3D.com. And you find us under that name online, social media, Instagram, LinkedIn. So we do all the trials we got to do. And if you follow us, you see pretty much every week what we do, new stuff, also maybe open hirings, which we might have. So it's worthwhile following us, I guess. And yeah, so we are really looking forward to that.
Perfect. Everybody, you already know what to do. Go follow Candidate 3D on media. Thank you very much. Guys, remember that you can find more information, interesting articles, and interviews directly on our website, controlhub.com/builder-nation. We're gonna love to hear from you. Thank you very much for being part of this community. We're gonna see you at the next episode. And Yves, thank you very much for joining us. It has been a pleasure.
Same here, my absolute pleasure. Thank you, Sam, for having me. And yeah, it was great, and have a great day.
When building the future is your priority, tedious procurement processes should be last on your list. The problem is that purchasing data is scattered across spreadsheets, receipts, emails, and messages. Tracking it all sucks and makes it easy to commit mistakes. Introducing the Control Hub Way, the all-in-one purchasing software for hardware companies. Buying parts, services, or office supplies? Submit a quick purchase request to buy from your list of approved vendors, or buy from a new provider. Buying from approved vendors is even easier. Import your shopping cart directly into your purchase request using our checkout integrations. When the order is ready, submit it for approval. We'll ping all pre-designated approvers both via Control Hub's website, email, and Slack notifications for a faster turnaround. If you need a PO, we got you. Generate it in one click. Online purchase? Boom, virtual card. Do an automatic 3-way match, pay invoices, and sync everything live with QuickBooks or NetSuite. Purchasing just got a lot easier. Control Hub. Get back to building.